Hello everyone, my name is Haibo Chu. Now I would like to present our paper, Seeing Face Recognition with Synthetic Data. The authors of this paper are from JD Explore Academy, the University of Sydney, and Tencent Data Platform. This is the outline of our presentation. Firstly, we discuss the problems existing in current large-scale face recognition systems. Then, based on our analysis and observations, we address the above-mentioned issues by utilizing the synthetic face images generated by popular generative adversarial networks. Next, we explain how to efficiently and effectively leverage synthetic data for face recognition. Lastly, we show the experimental results on popular face recognition benchmarks to demonstrate the effectiveness of our method. The past decades have witnessed extraordinary progress on deep learning-based face recognition, mainly owing to large-scale training datasets. However, collecting large-scale face images from the internet are struggling with the concept of all involved identities. Also, the collected training datasets really have an extremely imbalanced distribution on different classes. For example, head classes have a large number of samples, while tail classes only include a few samples. In addition, this training data also lacks detailed annotation on face attributes such as pose and expression. Meanwhile, we have observed a significant progress on face synthesis using GANs and 3D-MM, which demonstrate the possibility of enabling the process control of different face properties, such as identity, pose, expression, and illumination. Sometimes it's very hard, even for human themselves, to distinguish real and synthetic face images. Inspired by these advancements on synthetic face generation, we can synthesize large-scale face images of non-existing identities without suffering privacy issues. Furthermore, with the controllable face synthesis, we can easily investigate the impacts of different face properties and facial attributes on final performance. Therefore, in this paper, we explore the potentials of synthetic face images for face recognition. Here we start with some simple experiments. For simplicity, we refer to the model trained on synthetic and real face datasets as same face and real face. Firstly, we perform a cross-domain evaluation on them. As we can see from this table, both of them achieve nearly perfect accuracy when training and testing on the same domain, while the performance are degraded on a different domain, revealing the domain gap between synthetic and real face images contributes to the performance gap. We also visualize the feature distributions on real and synthetic face datasets. As shown in this figure, we found those synthetic face images have a much more compact distribution than the real ones, suggesting they poor intra-class variations. Here we present the overall framework. The identity mix-up module is proposed to enlarge intra-class variations. The domain mix-up module is introduced to further alleviate the domain gap between synthetic and real face images. Now we're going to discuss them in detail. We introduced the mix-up technology into identity coefficient space by interpreting two different identities as a new intermediate one, with changing the label correspondingly to enlarge intra-class variations. Here we provide some examples where an identity gradually and smoothly changed to another identity. As shown in this figure, we found the generated intermediate face images are also high fidelity. To further alleviate the domain gap, we also propose to mix up large-scale synthetic face images with a small number of real face images during training, where the labels change accordingly as the supervision. Now we provide the experimental results to demonstrate the effectiveness of synthetic face images for face recognition. As we can see from this table, the accuracy remarkably increases when enlarging both depth and width of training datasets. Importantly, employing the identity mix-up for training consistently improves the performance of all datasets, revealing its greater generalizability. Here we explore the impacts of training with synthetic face images, real face images, and a mixture of them. From this table, domain mix-up brings a significant and consistent improvement over the baseline method and different settings. When we continue to increase the number of real face images for training, such as Mix2K20, the performance can be further boosted from 95.78% to 97.65%. Lastly, we show the impacts of different face attributes on face recognition. Experimental results on pose and illumination demonstrate significant improvements over now, possibly due to their more diverse distributions. Besides, we found all of four settings are remarkably improved with the proposed identity mix-up, since it can be regarded as a strong data augmentation. Thanks for your listening.